Good morning. Today we're going to talk about the nervous system. To do that, we're going to watch this brief vocabulary video. Some of you might be familiar with vocabulary and you might be rolling your eyes right now, but there are worse things than having to watch these videos, and it just does give a brief overview of how the nervous system works. So it's worth your time. After that, we're going to check out the Franklin Institute's interactives for the brain, and I'm going to talk you through those. So here we go.
Oh man,
What's up?
is that a bugging you?
Oh yeah, I hear it
This is
too.
bugging me out.
Right?
How am I gonna learn about the nervous system with that thing buzzing around?
It's Flowcab at your service. Listen, we're here today to talk about the nervous system.
Hey, wait, hold up, stop the song. Something big just landed on my left arm.
How does your brain know what your senses feel, huh? It's your nervous system getting the job done. Don't think you have nerves in your skin? Well, you're wrong. And nerves are made of bundles of neurons, specialized cells that carry messages fast. Believe it, and they don't even need a messenger bag. Most nerves connect to the spinal cord, and its mission is to act like the highway of your nervous system. The spinal cord zooms the message to your brain, which unpacks the message and tries to explain what it means, and the brain controls your response. In this case, it says,
Move your left arm.
that message goes back, spinal cord to nerve. Your arm moves, and you squash the bug in a blur. Word, the central nervous system is the name that pertains to your spinal cord and your brain. And the other neurons and nerves in a different position, they make up the peripheral nervous system, abbreviated as CNS and PNS. Saying the full lines will leave me out of breath.
Chilling with the systems, I'm like, oh hey. Moses with the neurons, spinal cord, and brain. Controlling everything I think, do, and feel.
That's the nervous system, y'all, you know the deal.
Chilling with the systems, I'm like, oh hey. Moses with the neurons, spinal cord, and brain. Controlling everything I think, do, and feel.
That's the nervous system, y'all, you know the deal. The peripheral nervous system has two functions, so we can divide it into two parts. The somatic nervous system part runs all voluntary actions from the start. It sends info to your CNS, then receives messages, makes your muscles flex. That's what happened with the bug before. That was your somatic nervous system.
Yeah, sure.
And there is a kind of involuntary action that the somatic controls. Here's what happens. If you touch a pan that is hot, a reflex takes place. An impulse is shot to your spinal cord through sensory neuron. Another impulse is shot back through motor neurons. Skips your brain so your reaction's fast. That's the somatic system and its various tasks. There's another crucial part of the PNS. For most involuntary actions get done by the autonomic nervous system. It's active even when you're still or asleep on a mattress. Regulates your body's internal machines so your heart always beats and you always breathe. It's in charge when you call for sneeze, when your pupils expand in the dark to help you see.
Chilling with the systems, I'm like, oh hey. Moses with the neurons, spinal cord, and brain. Controlling everything I think, do, and feel.
That's the nervous system, y'all, you know the deal.
Chilling with the systems, I'm like, oh hey. Moses with the neurons, spinal cord, and brain. Controlling everything I think, do, and feel.
That's the nervous system, y'all, you know the deal.
Got it.
Nice.
Now, what were you saying about the nervous system?
You're gonna have to rewind that.
Okay, so that explains that the nervous system controls everything that you think, do, and feel. And there's three parts of it: the brain, spinal cord, and the nerves. And that's actually broken down into two systems called the peripheral nervous system, which are your nerves, and the brain and the spinal cord. And it's a complex network constantly sending messages through your body. So when we started talking about living versus non-living, one of the criteria for all living things was to be able to respond to stimuli, and that's to keep you safe. And we're constantly responding to the stimuli in our environment. There's a stimulus, and then our body responds to it in some way. So the first thing I wanted to show you is that the Franklin Institute has a bunch of different interactives having to do with the brain. And I'm there now. You can see it on my screen. And your activity today is to just choose some interactives to explore. I'm going to do a couple with you. The first one I'm going to go into is build your network. You're going to find out how information travels to the brain through special cells called neurons. So neurons, I showed you a photograph of when we did the cell diversity tour. Neurons are extremely specialized. They have one main job, and the neurons can they form these complicated networks that send signals through their connections. So a bunch of neurons make up your nerve tissue, and there's 3 parts to a neuron. There is the dendrites. Okay, they remind me of tree branches. And the axon is at the other end of the neuron. And then there is the nucleus in the center. The nucleus is called the cell body. You can see it labeled right there. And the axon starts right there, and the axon terminal is the very end. And then here is the dendrite. It's a more complex image right here than the one on the last screen. So I'm going to read this out loud to you. Feel free to read along with me. Neurons are great communicators. Information travels through the brain along special cells called neurons. Each part of the neuron has an important role. Dendrites, the hairs surrounding the cell body, receive information. The cell body combines information from different dendrites. The long tail-like axon moves the message along. Information jumps to the next neuron from the axon terminals. It takes both electrical and chemical signals for your brain to send and receive information. First, chemicals called neurotransmitters carry incoming messages across the gap between 2 neurons. This rush of chemicals triggers the receiving neuron to fire off an electrical signal that moves the message along the cell. Neurotransmitters at the end of the neuron then pass the message on to the next cell. Every time you learn something, you form connections between neurons. Over time, important neural connections strengthen, while less used pathways fade away. That's actually called pruning. We create new neurons and new pathways between neurons throughout our lives. That's why it's important to be lifelong learners. You have to use your brain in order to keep those connections between neurons. It's important to do that. So if you've ever seen the movie Inside Out, where the memories are fading away, okay, so all that information that's stored in her brain that she doesn't use anymore or need anymore, it goes away. I forget what that place is called where all the memories go, but they turn gray and then they get chipped away. That is when your brain is pruning, okay? Getting rid of the less used pathways and rid of memories. All right. So in this passage that I just read aloud, it mentioned neurotransmitters, which are these chemical signals that get passed from cell to cell. I'm going to show you a quick infographic about neurotransmitters. There are many different types of neurotransmitters, but some of them you've probably heard of before. And since they're chemicals, they have a molecular structure, as shown in this infographic. So adrenaline is a commonly known neurotransmitter responsible for fight or flight. So we talk about adrenaline a lot with sports, okay? Adrenaline is produced in stressful and exciting situations. It increases the heart rate and blood flow. It leads to a physical boost and heightened awareness. So we often rely on adrenaline when we're in sports competition, or if we're watching a scary movie, or if we're in a fight. That adrenaline's really kicking up, and the neurons are sending adrenaline impulses, okay, through the nerves, back and forth. Dopamine is another one. That is a pleasure neurotransmitter. We mostly use dopamine nowadays with our screens, okay? Every single like or comment we receive on social media is triggering a release of dopamine, and that is related to feelings of pleasure and addiction. And it causes us to repeat behaviors because we want to keep getting those dopamine releases. So it's an actual serious thing nowadays because we are also reliant and addicted to screens and getting all of that attention from our Snapchats and whatnot. That's releasing dopamine, and we come to rely on those releases more and more. Okay, serotonin is another one, responsible for moods. It contributes to well-being and happiness. It helps our sleep cycle and our digestive system, and it's affected by exercise and light exposure. So it's a real thing to say, like, go outside and get some sun. That vitamin D is good for you. That light exposure improves your mood. Okay, so does exercise. Really, really important. Even if you do 10 jumping jacks, okay, if you're feeling down, just try to get into the habit of doing a little bit of exercise. It improves your mood. Okay, so lots of neurotransmitters. Each chemical is responsible for something. So back to the interactive. Okay. We talked about the science behind neurons and what they do. And now I am going to build my own network, okay? So what you can do is add a neuron. Okay, so that's one nerve cell. And then I'm going to add another one. And it's my job to connect them. And they only create neural pathways if the axons are near a dendrite of another neuron. Okay, it doesn't go the other way around. They don't communicate that way. So the axon is going to send a chemical or electrical impulse to the dendrites of another cell. And I'm going to add some more neurons here. It's also important to mention once again that the axons of one cell never touch the dendrites of another cell. There's empty space in between. So I'm making my neural pathway. There's no right or wrong way. I mean, I guess there is a wrong way, but where I put them is not really all that important as long as the axons are close to dendrites. Okay, so I have 5 neurons there, and I'm gonna see if it works. Ooh, okay. So that is an impulse traveling through my neural pathway. Now, in our bodies, we have trillions of cells. So neurons in these nerve tissue sending messages all day long. They're going to send messages to our brain, and then our brain is going to tell your body what to do. Okay. So that's the first interactive I wanted to share with you. I don't know how I am on time. And then I want you to just take a few minutes to explore these different interactives, okay? Each one has good information about how your brain works and probably answer some questions that you might have had at some point in your life, like how we recognize faces and objects, okay? You can actually make your own face out of different things, which is pretty fun.